Hey everyone and Assalamu alaikum. In this video, we are presenting our project which is titled as Electric Gas Lighter. This project demonstrates how a low voltage DC source can be converted into a high voltage spark for gas ignition using simple electronic circuit. And to provide you with a project overview, the electric gas lighter is an electronic alternative to conventional fuel-based lighters. And instead of using the flammable fuel, this system generates a spark electricity. And the basic components that we would need for this project would be a DC source of 3.7 volts, an on and off switch, preferably a button switch, a D880 transistor, a step-up transformer, a diode of 1N4007, and a 470 microfarad capacitor and a 330 ohm resistor. As you can see, all of these elements are readily available in the market and our components are very easy to find. The circuit diagram is also very explicitly drawn, and you can easily make out all the connections. So to practically demonstrate it on the Vero board and to arrange the element and arrange the components of the circuit, let's move on to the Vero board. As you can see, all of the components, they are neatly arranged on the Vero board, and the output terminals and the input is defined. So this is the first input, this is the input, the DC source of 3.7 volts. The diode is present here, which is connected to its positive terminal, and there is a capacitor which is connected to its negative terminal, and then there is our button, the button switch, and a resistor which will limit the current. The transistor, which is one of the most major components of this whole circuit, and the transformer, the control, and everything necessary is present in this black box. And let me remind you that this transformer is a step-up high voltage transformer. Now, the main question in this circuit arises is that we are using a DC source as an input. However, our transformer always works on AC sources. So what is the major component that is converting this DC source into the AC source? For this purpose, we have to look into the function of the transistor, as transistor is the major component present here. This transistor, due to electronics fluctuations, convert this DC source into an AC signal, kind of like an AC signal for the transformer to operate on it. Okay, and these are the output terminals, and this is the whole circuit. The circuit could be made more neatly or it could be concised, but to make it student friendly and for educational purposes, we have made it on the cardboard.
So moving on to the practical demonstration of the model. So we are going to push the button, and this DC source will provide the current, and the transistor will convert the DC source into fluctuation to make the transformer work on, and our spark will generated here in the output terminals. So make sure that no person is standing here, because it generates a very high voltage spark of kilovolts, and it will be very dangerous for someone standing here. So now moving on to the demonstration, we are going to turn on the power supply and to activate the model, and I'm going to push the button and you will see the spark here. So here I'm going to push. As you can see, our DC I'm going to show you again to show that the spark is continuous. That's how our transformer is converting our low voltage into continuous spark, steady current. Moving on to the next part of future implications, we can modify our electric gas lighters into rechargeable ones. The circuit can be developed into compact and rechargeable gas lighters powered by lithium-ion batteries, and these devices would eliminate disposable flints and reduce fuel-based waste. And we can further modify it into portable spark ignition devices, and this principle can be used to design portable ignition tools for camping stoves and laboratory burners. So that's all for our electric gas lighter project, and thank you for watching the video.